Welcome to Zuluba Consultants. In this video, we want to look at how we perform calculations under the topic electricity when we are looking at the subtopic series circuits. Do not forget to subscribe to this YouTube channel and following us on Facebook. So when it comes to series circuits, there are 4 points that you need to know when you are performing calculations under series circuits. The first one is the current in the series circuit is the same at any point. And so this reason we are saying I is equal to I1, which is equal to I2. So at any point in the circuit, the current is the same. The second point that we ought to know under series circuit is the EMF, which is the electromotive force, which is in the cell here, is equal to V1, which is the voltage in resistor 1 plus the voltage in resistor 2. So this is the second point that you need to know. EMF is equal to V1 plus V2. The third point that you need to know is how to calculate the total resistance. The total resistance is given by the sum of R1 and R2. So when you have resistor 1 and resistor 2, you can find the total resistance in the series circuit. Last but not the least, you also have to know and remember the Ohm's law, which is the fourth equation. So once you know these 4 equations or these 4 statements, you are able to answer any question under series circuits. So let's see this example and see how we can apply the 4 equations. So you can see from the example here, we have the first resistor has 1 ohm, the second resistor has 3 ohms. Then the EMF is 12 volt. So let's see the first question that we have. It is asking us to find the total resistance. Now, when you have these 4 equations, you look at what the question is asking. The question is asking us to find R, which is the total resistance. So you look at the equations that you have, which equation has the letter R, which represents resistance. You notice that equation 3 and 4 have resistance. Further, you need now to choose which of the 2 equations am I going to use. You notice that equation 3 has resistor 1 and resistor 2, while equation 4 has the voltage and the current. When you look at the example, it has not given us the current, so we cannot use equation 4 to calculate the total resistance. Hence, we will go to equation 3. So equation 3 is telling us that resistor 1 plus resistor 2 gives us the total resistance. So what is the information? We have resistor 1, it is 1 ohm. Then resistor 2, it is 3 ohms. So when we add the 2, we'll get 4 ohms as the total resistance in this circuit. The second example that we can calculate from this series circuit is finding the current that is passing through the cell here. We know that current is measured in amps, and the symbol used to show current is I. So current, we use the symbol I. Now, when we look at the 4 equations that we have, which equations have the letter I? You'll notice equation 1 and equation 4 have this letter I. Now, what is equation 1 telling us? It is simply telling us that the current is the same at any point in this series circuit, while equation 4 is the Ohm's law that relates resistance to voltage and current. Now we ask ourselves, the information that we have, which of the two expressions or equations can we use? You'll notice that we cannot use equation 1 because we do not have the current which is the same in this circuit. So we have to settle to equation 4 that will help us to calculate the current. Now equation 4 is saying resistance is equal to voltage divided by current. So we need to make current the subject of the formula by dividing both sides with 1, then we cross multiply. You have resistance multiplied by current is equal to voltage. Then you divide by resistance, you divide by resistance. So these two will simplify, then we'll have current is equal to voltage divided by resistance. Now, the first question, we calculated the total resistance, and it helped us to know that the total resistance in this series circuit is 4 ohms. What else do we know about this series circuit? We have been given the total EMF, that is the total voltage in this circuit, which is 12. So the V is 12 volts. So we can now plug those two in the equation where V is 12, you say 12 volts divided by the resistance is 4 ohms. When you divide 4 into 12, you get 3 amps. So this becomes the current that is passing through the cell. So we have 3 ohms as the current passing through the cell. The third question that can arise from this series circuit that we have is for us to calculate the potential difference that is passing through the 1 ohm resistor. Now, what is the potential difference? We know that the potential difference is basically the voltage that is passing through this resistor. So how do we get the voltage that is passing through the 1 ohm resistor? We know that there are some equations here that can help us to answer this question. The first equation that will help us is equation 1. How? Equation 1 is helping us to know the fact that the current that is passing through this point is the same as the current passing through the whole circuit. So even at this point, the current is 3 amps. So that is the first information that we can get. The current at resistor 1, we are saying it is also 3 amps. What else do we get from this information? The resistance at that point is 1 ohms. After we know this, they are asking us to calculate the potential difference, which is basically the V. So when you have these two, and you are asked to find the V, which equation can we use? We can use equation 4. Now, with equation 4, we know that R is equal to V divided by I. So they are asking us to find or to make V the subject of the formula. So we'll cross multiply and we'll have V is equal to R multiplied by I. So what is our R? It is 1 ohm. Then we are multiplying this with 3 amps. 1 multiplied by 3, we are getting 3 volts. So this becomes the potential difference that is at resistor 1. The fourth question that we have is for us to calculate or to find the potential difference that is passing through the second resistance that has 3 ohms. So how do we calculate this? We can get the data about this question. The resistance that we have there is 3 ohms. Then what is the current? We remember how point 1 is working. The current at any point is the same. So even at that point, the current is 3 amps. When we have these two, we have been asked to find the voltage, which is passing the second resistor. So you find that Ohm's law again comes to play, where we are saying resistance is equal to voltage divided by current. So voltage is equal to resistance multiplied by current. The resistance is 3 ohms, the current is 3 amps. So 3 multiplied by 3 gives us 9 volts. So this becomes the voltage that is passing through the second resistance. With this question, you can also have the second option, where you can use equation 2 to find the PT that is passing through the second resistance. How do you use that equation? We are saying EMF is equal to V1 plus V2. What is our EMF? It is 12 volts is equal to V1. We calculated that it is 3 volts. V1 is 3 volts plus V2. So when 3 crosses the equal sign, becomes negative, we will say 12 volts minus 3 volts is equal to V2. So V2 will be 12 minus 3, which is 9 volts. So again, using the second equation and using the Ohm's law gives us the same answer.